Hello everybody, my name is Gatis Kandis and today I will show you how to find out the altitude of your drone if it is very high or anything else that you can tie a string on and stretch it all the way down to the ground. So I draw this little sample here on the paper. So that's gonna be ground, and then up here where my thumb is, that's where the drone or anything else would be. And so, as I mentioned, you have to tie a string on it, and the string has to hang all the way down to the ground. So that's GR for ground or grass or green, whichever you choose. Okay, if the drone is very low, like 2-3 meters, it's easy. You just get a measuring tape and you can measure it that way. But if it is high up, like 50-100 meters, it's very hard to measure it precisely. I know some drones actually have built-in GPS and they will tell you how high they are, but this is actually not guaranteed height because that's just approximate. And some drones doesn't have height measure at all, so this will be a very easy method how to find out the height. So then to find out the height, you take the string which is hanging down from above, and so you move it to the side, and as you can see, string is lifting up because basically if you go all the way around it would make a circle. You don't need to make a circle, you just move some distance, till the string lifts up like so. And so now I'm gonna mark that point with a pen. Okay, so I marked it with a pen, and so when you move the string that way, it lifted up that high from the ground. So now I'm gonna draw some right angle triangle, and that's gonna help us find out the height of the drone. Okay, so I drew a couple right angle triangles around the string I had in the beginning and the dot where the string was reaching. And so as you can see, now I have a big right angle triangle, and then I have a bit smaller right angle triangle as well. So it is very easy to measure D, which is a distance how far you are walking from the original starting point all the way to where you want to stop. And then the X is another one which is very easy to measure. That's basically the height of the string lifted up from the ground at the moment, which is clearly visible here. And so now then this is gonna be called H, which is height for the drone. And also this here is H because it is exactly the same length. As you remember, when I pulled the string, it ended up there. So that is also H. And then I have added just a couple more letters because we're gonna need C, which is the hypotenuse of the big right angle triangle. And I also added E, which is the height from the drone to up to this point. And the G is the length of this side of the big right angle triangle. And now when we have established all the letters for all the sides of both triangles, we can use Pythagoras theorem to calculate H if we only know the D, which is a distance which we can measure by walking along the ground, and the X, which is the height at which the string lifts up from the ground as we have been walking. So without further ado, I'm gonna show you a few simple steps how to calculate the H. Okay, so let's start with the basics. First of all, H squared equals C squared minus G squared. We are talking about a big triangle because in a big triangle, C is a hypotenuse, and that's why H squared equals C squared minus G squared. And another way to express H is H squared equals D squared plus E squared, which is in case of a smaller triangle, because in the case of smaller triangle, H is actually hypotenuse, therefore H squared equals D squared plus E squared, because this side is E. And now because H squared equals H squared, we can actually make a new equation, meaning now D squared plus E squared, which is from this one, equals C squared minus G squared, which is from the first formula. And E equals H minus X, which you can actually clearly see here. H is the whole long one minus X if you subtract a little X, so now that becomes C. So we're gonna need that to continue our calculation. And to continue our calculation, now we are using this formula here. So we write D squared plus, and instead of E, we are writing now H minus X. And because E is squared, so we have to square that. So H minus X squared, and then again equals C squared minus G squared. And now in the next step, we simply express H minus X squared with a very known formula. So now we write D squared plus, and so H minus X squared equals H squared squared minus 2hx plus x squared, and then again equals c squared minus g squared. And now we're gonna use c squared equals h squared plus g squared from the big right angle triangle, because we're gonna need to replace this c squared so we can continue with our calculation. Okay, so now we continue with this formula, and instead of c squared we are writing h squared plus g squared. So that's the resulting formula when the c squared is turned into h squared plus g squared, as you can see here. And so now we can actually start striping out some of these because they equal to 0. For example, there is h squared on this side of the equal sign, and there is h squared on this side as well, which means we can stripe those out. So here we go, don't need those. And then another thing we can stripe out is g squared minus g squared. Again, that becomes 0, so we can stripe those out as well. Okay, so here we go. So now I'm gonna rewrite this formula in a simpler way. Okay, so we are nearly there. As you could see, all that was left over is d squared plus x squared equals, and then because I brought minus 2hx on the other side of equal sign, so that became plus. So we are nearly there. I'm just gonna swap these around now so it'll be easier to express the h. So the next step was the simplest one because we simply swapped them around, and so now to get h, all I have to do is divide the whole thing with 2x, and so h is gonna be equals to d squared plus x squared divided by 2x. Okay, so as I mentioned, I divided the whole thing by 2x, and the final result is h equals d squared plus x squared divided by 2x. And so now when we know the formula, I can actually go outside and test it in real life. And funny thing is that I'll be actually using exact same string because this is the only string I got at home at the moment. It can actually hold a few kilograms. It's a very strong string. And so yeah, I'll see you on the outside. Okay, so I have arrived at the park. The drone is ready over here, and then from the drone over there 10 meters away, I pre-measured it 10 meters because it will be easier to use it in the formula. There's a measuring tape. And so once I go, I'm gonna probably go 50 meters high, and then the spool is gonna be touching the ground over here, and then I'm gonna pull it all the way there where it's 10 meters from here, and then I will be using that measuring tape to measure how high it is above the ground. And so then I will have these two values which I'll be able to put in the formula and be able to measure the height of the drone. Okay, so without further ado, let me get started. Okay, it's ready to take off. So I'm gonna go up to like 50 meters. Okay, we are at 25 meters. I think it's a little bit windy up there. 38 meters, 48, 49, a little bit more. Okay, we are at 50 meters according to the remote, but now I'm gonna actually measure it and find out whether that's really true. Okay, as you can see, the spool is on the ground here, and now I'm walking over there, 10 meters from here. I'm gonna measure the height from the ground there. So here I go. Let's do it. Okay, so as you can see, here it is, a little distance here. And it is 60 centimeters. 60 centimeters. Okay, so that was 60 centimeters over there. So now I'm gonna put the values in the formula and test whether it really is 50 meters high. Okay, so just before I go, I want to show you how stable it is in one point, because right now the camera is not moving, and you can see the drone is like staying pretty much in one place, and this is 50 meters high. Let me show you when I zoom out. See, I zoom out, and yeah, it is all the way up there 50 meters high, and it is not moving at all. It's just like staying in one position, and just all the lights are flashing as it should. And so now I'm gonna pull on the string, and you probably gonna be able to hear it work harder. Okay, gonna pull it now. Can you hear it? Can you hear? Can you hear? Like it was like so super strong, and it even like moved the location a little bit. Okay, I'm gonna bring it back down now because it's getting low on battery. Okay, here is landing. There we go. Okay, because I pressed auto landing, so it came down automatically. Now I will be able to calculate the height. So 10 squared is 100, so 100 plus 0.6 times 0.6, so that's 100.36, and now we have to divide it by 2 and also have to divide it by 0.6, and so the total result is 83 meters. Which is not quite 50 meters, and I kind of believe the drone that it was actually 50 meters, but probably the reason it's showing 83 is because in the beginning the string was 1 meter high, but then because I pulled it lower, I pulled it down to 60 centimeters. That's why it's showing this result, because I thought I needed to pull the string, but I didn't. Because if we do calculation with 1 meter, then it would be very close result. So that would be 100 plus 1 equals 101, and then divided by 2 and divided by 1, so we would be very near to the 50 meters that the drone said. But like I said, because I thought I needed to pull it straight and I pulled it lower than it actually was in the beginning, that's why it showed the wrong result. And that is how you very easily can calculate the height of something that is up very high. I'm just gonna hold it like so for a little bit, just in case you want to know what all the steps are, so they are clearly visible. And so yeah, that's a very simple way how to find out the height. And thank you very much for watching, and I will speak to you soon.